Okay, so how is everyone today? Good, I hope. I hope you had a nice Monday break. All right, so then just a reminder about logistical matters in the class is that we have two varieties of homework. One of them is called online homework. That's the thing that you do on WebAssign through a web browser. It gives you a question in a little box to type your answer into, or maybe some of them are multiple guess questions, that kind of thing. That's WebAssign. We are referring to those as OHW for online homework. And then we have written homework, which are these things that we're turning in today. That's where you download some pages, you print them, and do them and turn them in at the beginning or end of the lecture as indicated. Good. Any question about that? The homework? All right, and then we have quizzes every other Friday. Now, there's a Friday 2 days from now, but we don't have a quiz on that one. We have a quiz on the Friday that's 2 plus 7 days from now. Any question about that? All right. So then, here we are. We've been talking about exponents and operations and things like that. And specifically, we have kind of three operations that we're talking about a lot. We have add, which is exactly what you remember it to be from grade school. And then if you do add over and over again, then that is a important enough and common enough circumstance that it has its own name. For what? So what's the name for add over and over again? Multiply. And then, so if you do multiply over and over again, then that is important enough and common enough of a situation that it has its own name. What's the name for doing multiply over and over again? Caret. Caret, right? So it's denoted with caret. And generally that kind of thing is called exponent. Okay, so we're talking about these three. We're going to be talking about these all semester. Now, so it's this one is repeated previous one. And the chain goes on as far as you care to take it. We don't talk about it in this class. But, if you just are interested, just like to know these things, then generally this process is called tetration, and the next one in the sequence is also called tetration. So if you do repeated exponent, so you don't need to write this down. I'm just writing this down for your own, for those who are curious. So the next thing is denoted like this, as an up arrow. So you could write like 3 up arrow 4. The next one is just written with 2 up arrows. So it would be up arrow, and so they become regular after that. So like the next operation that comes after 8 up arrows, that's denoted with 8 of them. The next one has 9. Okay, but we only talk about these in this class. Okay, so this is us. Specifically, the thing that we ended with last time is we said that there is such a thing as distribution, and what that is that's a relationship between two operations. So there is a distribution for these. Multiply can distribute over add, and there's a distribution for these. Exponent can distribute over multiply, but there is not a distribution for these two. It's an error to try and do that. And specifically last time we talked about binomials and squaring a binomial, and we talked about FOIL and that kind of thing. Okay, so there's a distribution for this. The distribution you could say looks like this. So A plus B multiply, I'll write n. So A plus B multiply n. There's a distribution for that. It is A multiply n plus B multiply n. And for this one, there's also a distribution. And you could write, so just taking these three symbols, A, B, and N, and writing them also here. So A, B, and N. And then I'll write the parentheses in the same place, so these. But instead of doing distribution of multiply over add, we're going to do distribution of exponent over multiply. So now this one is a multiply. And what's this one? Caret. Okay, so now the rule is that this is A caret N, and then multiply B caret N. And then we also have to pay attention to the fact that under normal circumstances, when you're doing math on the street or whatever, you don't usually write the carets. Rather, you write superscripts. So writing this in a more typical fashion would be something like this. A multiply B with exponent n is A with exponent n multiply B with exponent n. So that's a more typical way to write it. But what that is that's distribution of exponent over multiply, and this is distribution of multiply over add. Okay, good. Any question about this? That's kind of what we did last time. So now we're going to kind of get into some rules to calculate various expressions with exponents quickly. So some of the exercises that we're doing, maybe some of the ones we turned in, or maybe some of the ones that are posted, I can't remember anymore. But they have instructions that say something like, take this expression that has exponents and then expand it all the way out until there's no more exponents and it's just a bunch of multiplies. You know, and it is admittedly tedious to do that. Okay, so we're going to do that just on this first group of exercises, and then we're not going to do that anymore. We're going to just use the rules. So today is basically the rules that we're allowed to use. But just because we're going over these rules today doesn't mean that it's permitted for you not to follow the instructions on the exercises that are already posted. Okay. So, to that end, we have associativity. Associativity. So, generally, to associate means to make a group, like when you're using associate in a general context. In a math context, specifically when you're talking about associativity, in a math expression, you're talking about adding or removing some things that start with P. What's their name? Starts with P. What is it? Okay. Parentheses, right? So adding parentheses into the expression or removing them. Okay? So concerning add. Add is associative. It's associative because if you take three numbers, A, B, and C. You take three numbers, A, B, and C, and suppose we're going to add them all up. So I put an add here and put an add here. Now, analyzing this with the order of operations, I can see that there's two operations, they're both add, and therefore they're tied. But the order of operation tells you how to break all ties, so which operation, according to the order of operations, is first? That one. Okay, so the order of operations indicates that that happens first. Okay? So that means that if I rewrite the expression like this, if I say A plus B, and then put that in parentheses, and then plus C, like that, then these two are the same thing. Because those parentheses, in some sense, are superfluous. All that those parentheses are saying that the stuff inside of them has to happen first. But the order of operations already said that that one happens first. So right here, there's nothing is said so far. Associativity comes in when you say that, in fact, this is also equal to this. A plus B plus C. So it's saying that you can move the parentheses over to the next pair and do it that way. So associativity is the statement that all of these are the same. All right? Concerning multiplication. Multiplication is associative. because I can just copy paste this entire thing and then do a find and replace all the pluses with multiplies. So I'll just do that. So A multiply B multiply C is the same as in a group A multiply B and then multiply C for the same reasons, right? Two multiplies, two operations, they're all multiply, so they're all tied. The order of operations says that the leftmost one wins, so that one goes first. Adding these parentheses does nothing because all that it's saying is, yes, we really are going to do that one first. And then if I move these parentheses over, then we have A multiply, and then in a group, B multiply C. So the fact that multiplication is associative, this is the statement of that fact. Okay, and there's nothing special about having 3. There could be 3 million things all multiplied together. And it's saying that you can select any pair that you want and do that one first. Go right ahead. Any question about it? All right. So now we have these 3 operations. We have add, multiply, exponent. Now add is associative, multiply is associative, and so now the question is what about exponent? And the answer is that it is not. So exponent is not associative. It's not associative. So what I mean is that we have two possible parenthesizations. So if we have A plus B, A, B, and C, and we put carets in between them, so like caret, caret, like that. And then if we parenthesize the first pair, so like this, then we could take those same 3 things, A, B, and C, so A, B, and C, and put carets. But instead, let's parenthesize the second pair. So ABC, all careted, all exponents like that, but done in this case in that order, and in that case in that order. These are not the same. Now I need to put a little qualification here. So this is generally. So what I mean by that is that you could pick like your favorite A, B, and C, and it might work for your favorite A, B, and C. But it's not going to work for any A, B, and C whatsoever. It's not going to work for every single combination of A, B, and C. So writing this without carets, but rather with exponents, this is saying that A to B to C, like that, is generally not the same as A to B to C, like that. Notice that, it's ABC, ABC, but we put the parentheses in a different place. So here's just one example is enough to show that this is right. So if you want to say something like every marble is blue, that's a statement. It's either false or true. You can show that it's false by producing exactly one marble that isn't blue. Okay, so here's the statement. All I have to do is produce exactly one triplet ABC to where this is not true. Okay, so for example, let's take 2, 3, 2. So 2, 3, 2, and 2, 3, 2. In the left column, I'll parenthesize it the first pair, and the right column, the second pair, like that. Okay, so now here I'll write this without carets. So this would be 2 to 3 to 2, like that. So now, what is 2 cubed? 8. So we're asking, what is 8 squared? So what's that? 64. All right, fair enough. So for this one, writing it without carets, this would be 2, and then in parentheses, 3 squared. All right, what is 3 squared? 9. So this would be 2 to 9. And well, what is 2 to 9? 512. So, you know, in grade school, you know, they make you memorize like the multiplication table. Every single digit times every other single digit. You need to have memorized 0 through 9 multiplied by 0 through 9. You got to memorize that. And then you memorize a procedure for how to, you know, if you want to multiply 2 3-digit numbers, then you do the thing, you know. So similarly, you know, it's good to memorize squares. So for this class, it would be really good if you memorized all squares up to 25, which is to say you should know 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way up to 25 squared. You should just know them. Those are the things you should just know. Similarly, you should know powers of 2 probably all the way up to 10. Even further would be better. Okay? Good. So now, are these two numbers the same number? They're not the same, right? Which means that if you put the parentheses like that, that's not the same as putting the parentheses like that. Okay, so that's all that we had to show. So not the same. And therefore, exponent is not associative. Exponent is not associative. So now here's the, so this fact is important on its own. Like, you should know that exponent is a thing that we deal with a lot, and furthermore, it's not associative. The next place where it's important is that in Math 1314, our class, it is an error to write two caret 3 caret 2. So that's an error. Or this one, 2 3 2. So it's an error to write that. So which is to say, you know, if you were taking a Spanish class or something, then it's an error to say sentences that aren't in Spanish. So then, so you must write. So you must parenthesize. You must add parentheses to say which one you mean. So you could do this one. So you could do something like 2 to 3 to 2, if that's the one that you meant. Or you could write the other one if that's the one you meant. Now, so notice that I preface this by saying in Math 1314. And I hope that leads you to think like, well, what about in other places? So in other places, yeah, you can write that. But we're not going to do it, and now we're just going to say it's an error to do that. The reason why is because I already hit y'all with the order of operations thing that's new to almost all of you. So if you had a pretty good middle school teacher or whatever, then they might have told you the ties are broken left to right, blah 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 thingy. But that's usually not the case. So so there actually is a rule for this, and that is, well, you can see that for these three, all of the operations are exponent, so they're all tied. So if we use the rules as we know them in our class, then we'd say we choose that one. But in actuality, the way it works generally in further sciences is that in the case of exponent, you actually choose the one furthest to the right. So the tie-breaking rule for us is that when you have ties for the tie-breaking rule is that for multiplies and divides, it's broken left to right. For adds and subtracts, it's broken left to right. But in other contexts, you've got to know that for exponents, it's broken right to left. But rather than saying that in our class, we'll just say it's just not allowed. It's just not allowed. Can't do it. Any question about it? All right. So we want to be able to have some exponent rules. So now one of our exercises, I can't remember if it's one that we're turning in today or one that is posted and we're turning in later. I can't remember. But we have an exercise that kind of looks like this. It says something like, here's an expression, x to 3 to 8 or something like this. I don't know. I'm going to put 8 right there and then like this. So it says to simplify this expression by carrying out a long and tedious procedure. Okay, specifically it says get this all down to multiplies so that there's no exponents, and then count up all the x's and figure it out. And the homework exercise specifically says something like arrange things in a grid. Okay, so then I'm going to do it in the way described and illustrated in the homework. So x to 8, that means make 8 copies of x. And because exponent is repeated multiply, that means they've all got to be multiplied together. So this would be 1, 2, 3, 4, 5, 6, 7, 8. Still 3 there. So there's 8 x's. Okay, so now I want to deal with this 3. So whatever this is, whatever I'm covering up, that exponent 3 means make 3 copies of that and then multiply them together. That's what it means. So whatever it is I'm covering up. Now I happen to be covering up all those x's. So rather than making further copies and going further to the right, I'm going to make copies of this and go up and down because I want things to line up nicely. So doing that, it will look like this. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that's the first copy. And then multiplied by 1, 2, 3, 4, 5, 6, 7, 8. The third and final copy. 1, 2, 3, 4, 5, 6, 7, 8. So now, just as a matter of counting, you could just count them up, starting at 1, and then you could observe that there's 24 of the x's. But here's what I want you, instead of doing that, I want to use some even better machinery and say, do you observe that all the x's are lined up in a nice grid? And do you observe that this grid has 3 rows and 8 columns? So if this is a 3 by 8 grid of x's, then how many x's are there? 24. And how do you get 24?
8 times 3.
You multiply the number of rows by the number of columns. Okay. So this is a 3 by 8 grid of x's. Therefore, there are 3 multiplied by 8 x's. So, x to 3 multiplied by 8, which is, of course, 24. All right, so that's neat. But the point of this remark is for us to have the general formula so that we don't have to do that ever again. What am I saying? So x to m, and then to n, like this. So what do you think the rule is? How many x's will there be in the end? M times n. So it will be x to m multiplied by n. Because whatever m and n are, whatever they happen to be, then we could make a grid, right? We could say, here's this would be a grid of x's with m rows and n columns. Okay, that's how many. Now, this is a nice formula. You're expected to just use it and memorize it. So here's an example of its use. So how about w to, I don't know, 17, and then squared. So how does it simplify? W to 34. Okay, so if you, on the homeworks where it says, expand it all out, so many multiplies and whatever, this would be pretty tedious. But besides those homework exercises, and there'll probably be a quiz exercises that says it, besides those, just do it this way, please. Okay? All right, so now a few comments about this. So the previous page, we said that that exponent is not associative. Okay, so now what this rule is saying, believe it or not, is telling you exactly the extent to which it is not associative. So the rule x to m to n equal x to mn is saying, so it's saying the following. So it sort of helps to write the carets in now so that you can see exactly what's happening. So notice that, that this is an equation. The left-hand side has three symbols, x, m, n, and the right-hand side has three symbols, x, m, n. So they both have x, m, and n. So the left-hand side has x, m, and n, and the right-hand side has x, m, and n. Now the parenthesation is different on each one. So on the left-hand side, observe that x and m are parenthesized. And on the right-hand side, m and n are parenthesized. So the parenthesation is different. Now, in this, so there's two slots where we're going to put operations in, right? There's a slot there and a slot there. So what operation goes in that slot? Caret, right? So that's a caret because it's x to m. And what about in that slot? So this one right here. Caret, right? So notice that on both sides that slot is a caret. So can you see it? It's the same on both places. So now it's the other one that is the curious one. So what about this one right here? That's a caret, right? Because it's this thing with exponent n. So this is a caret. And now, the fact that exponent is not associative means that if you move these parentheses over, if you move them over to the next pair, then that's not the same as what you started with. What operation goes right here? Multiply. So what it's saying, what this rule is saying, is that if you have those three symbols, x, m, and n, and they're like this, they're like that, and you move those parentheses over, blah, then that stays a caret, but now that one is a multiply. So this is describing exactly the extent to which exponent is not associative. It's saying that if you mess around with it, then it changes into a multiply. All right. Interesting. So that's the first comment there. And to be clear about the way this works is something like this. So on that exercise, on this thing up here, we said that x to 8 cubed, you know, or just using the rule, we said that this was x to exponent 3 multiplied by 8. Right? But multiplication is commutative. It commutes. So what does that mean? That means that you can switch the order, right? That means that 3 times 8 is the same as 8 times 3. So this is the same as this. And now using the same rule but in reverse, it's saying this. Those are the same. So notice that we just switched the positions of the 3 and the 8. That's curious. Now, the reason why that's the case is because in this green box right here, for reasons that we already said, so in this green box, there are 24 x's because it's a 3 by 3 rows and 8 columns of x's. So in this green box. Now I'm going to come up with a different green box, and I want you to tell me how many x's there are. So in this box there are 24. How about in this box? Also 24, right? Because, you know, turning the box sideways doesn't change how many there are. That's what this is saying. A 3 by 8 grid of x's has the same number as a 8 by 3 grid of x's. That's what that's saying. Any question about this? Okay, so then using this in a typical exercise, do something like this. So how about w, and then how about w to 4 multiplied by z to 3, and then raised to 8. Why not? Okay, so this is really a combination. Oh wait, we haven't done this. So I'm going to put this on pause for a second. I did something out of order. Sorry. Pause. Okay, so first I need to say this. But this is something that we already really did, but I just wanted to say it before I do that exercise. So if we have something like xy and then raise that to exponent 3. So we did something just like this last on Friday. So I'm going to do this just super quick. So this is saying xy, xy, xy. That's what it's saying. Because that exponent 3 means make 3 copies of it and multiply them all together. Now, I could drop the parentheses because those are all multiplied and multiplication is associative. Then I could sort all the x's to the front and all the y's to the back, and I can do that sorting because multiplication is commutative. So then, you know, we could understand this to be xxx, yyyy. So the most compact way to write this would be x cubed multiplied by y cubed. A group of 3 x's all multiplied together, a group of 3 y's all multiplied together. Okay, so then generally the rule is xy, so x multiply y, to n is what? Right, x to n multiplied by y to n. And we did this on Friday. We did that on Friday because what this is this is the distribution of exponent over multiply. That's what it is. So we already talked about it. Okay, so now that exercise that's on the previous page, I had written down w to 4 multiply z to 3 in a group, and then all of that, z to 3, and then all of that to 8. So, you know, that would be tedious to sort of expand down to individual multiplies, but let's not do that. Rather, let's use this rule and the rule on the previous page. So, what this is saying is that if you have a product xy raised to an exponent n, then it distributes in that way. So here, this is a product. And, you know, there's an exponent, so there's going to be a distribution. Now, to be clear about it, usually when you get accustomed to doing this, you won't do it this way. But I'm gonna insert this step so that you can see clearly what's happening. So I'll leave these parentheses here like this. So to 8 like that, and I'm just going to put parentheses around that. So this would be w to 4, and then multiplied by z to 3. So all I did was put some parentheses around those things, so that your eyeballs can follow where the 8 goes. So the 8 distributes, and you know that thing will get its exponent 8, and that thing will get its exponent 8. So it looks like this: w to 4 to 8, and then multiplied by z to 3 to 8. So is there any question how that distribution occurs? And then now this thing, each one of these, this is the rule on the previous page, and this is the rule on the previous page. So how many w's are there? 32. And then how many z's? 24. Any question about that? So a few comments just about writing. So one thing is that you'll find that some things keep occurring all the time. Like I'll keep using the numbers 13 and 14 with much more frequency than is justified, for the reason that that's the course number. And almost always when there's a W, I try to make sure that there's a 3 close to it, because I think it looks funny, because W's and 3's are just like turned versions of each other. You know? So that's cute and everything, but here's the deal, is that there's a whole bunch of y'all, and y'all are going to do a whole bunch of exercises, and that means that there's going to be a whole bunch of grading. So part of it is, you know, one of the graders is me. I grade stuff. But there's also graduate students who are poor and undernourished, you know, and all sad, whatever. And, you know, they've got to read what you write. Okay? So now here's basically the general rule, is that, you know, if we can't read your handwriting, it's by definition wrong. Even if it's just too difficult to read your handwriting, it's wrong. We're not going to grade it. Furthermore, if what you've written has more than one interpretation, then it's wrong. So, to be clear, here's an example. The numeral 2. So the way I write it, me personally, is I write it like that. That's how my 2's look. Okay. The last letter of the alphabet. In the English alphabet, I mean. Like that. Z. Okay, so now I don't do that to be cute. Rather, it has to do with, you know, how you interpret things. So now, here's the deal. If you write something like the following on your homework. Then how shall I interpret that? Should I think this is where they fell asleep doing the exercise, right? All right. So then, so, you know, what do you think? What could it be? What do you think? Any guesses? 22z? Ah, you're close. But it was actually supposed to be 2 multiplied by z multiplied by z. You couldn't have said it right. I would have said no, it's this other one. You couldn't have. It was a trick question. Okay? So now, this versus 2 multiplied by z multiplied by z. And now you laugh a little bit, but literally every semester it has been the case that I have found a student who writes their 2's and their z's so similar that they have confused themselves. And a 2z has become a 22 every semester. Similarly, another one is that the plus operator, plus, is written like this. Okay, and I don't know what letter in the alphabet T is, so I'll just say letter T, and you'll know what I mean. At least a lowercase letter t is written like this. So it has like a little foot thingy, little foot. So in the study of the way stuff is written and typed and things like that, that's called orthography and typography. So the little foot thingy, the little hook bit thing, it's called a serif. It's called a serif. So like in your word processor, you can select a font, and then one font category is called sans serif. And that means without feet. So it won't have these little bits. No, to that end, please tell me. How shall I interpret it? The answer is that I won't. You'll just get a 0. What could this possibly mean? Okay, so then in my head, when I was saying it out loud, I was saying t cubed plus t plus 2t. But if you submit something like this, it's just not going to be graded. Another one would be something like this. So the numeral 1. This is probably the biggest one, is that most of y'all, obviously not all of y'all, but most of y'all are Americans, and almost all Americans don't write their ones with a hook on the top, a serif. But I do, mainly because I'm a mathematician. I didn't really start doing it until I started teaching. Because here's the thing, is that we haven't talked about it yet, but nevertheless you're supposed to know of its existence. There's something called absolute value. And absolute value is written with vertical bars. And what it tells you is how big a number is. So like absolute value of 5 is 5. And absolute value of -6 is 6. Because that's how big -6 is. And so what about this? What does this mean? What's that? Really? Because I meant 1 minus 11. Again, I would have said the other one. Okay? Okay? Good. So now I make no requirement that you write things in the way that I write them, not at all. Rather, I'm telling you that if it is not clear what you've written, then it is by definition incorrect. Good. So, where are we? So we just did that one. Ah, yes. So now we need to talk about inverses. So we're gonna proceed in 2 columns, side by side. In the left column, we're going to talk about add, and in the right column, we're going to talk about multiply. So the first comment in the add column is that 0 is the additive identity. Because x plus 0 is x for all x. Okay, so then by identity, what we mean is that the element that is neutral with respect to add. So adding 0 is the same as doing nothing. So now we want to ask a similar question for multiply. So what is the multiplicative identity? So what is it? 1. So 1 is the multiplicative identity. Because x multiply 1 is x for all x. Now, a comment about this is that this is like the second or third, it's at least the second, and I think actually the third time we've written this down so far, and we've only had 4 lectures. So one reason is that this is an important fact. The second reason has to do with how to teach effectively. So the first rule of teaching effectively is that the stuff you say has to be correct. You can't just be talking nonsense. Okay? The second rule is that you have to repeat yourself because it's important to say the same things over and over again. The third rule is that you need to repeat yourself because it's important to say the same things over and over again. So 0 is the additive identity, 1 is the multiplicative identity. So A and B are called additive inverses. When A plus B is 0. So, for example, 4 and negative 4 are additive inverses because 4 plus negative 4 is 0. 2 and 3 are not additive inverses because 2 plus 3 is 5, which isn't 0. So now, we want the analogous statement over here. So A plus B are called multiplicative inverses when, all right, so now I'm going to read this one again and stress it. So on the additive inverse side, A and B are called additive inverses when you add them and you get the additive identity. So what do we need to write over here?
A times B equals 1.
Good. Because now the statement is that A and B are called multiplicative inverses when you multiply them and get the multiplicative identity. All right, almost done. So all x in the reals have an additive inverse, so all of them do. And it's found by negation. Which is to say, you take that x and then you negate it. So the additive inverse of 5 is negative 5. The additive inverse of negative 8 is negative negative 8, which you'd probably just say as 8. So now, 3, look, this is a 2 right there. So this is a 3. Okay, so now all x in the reals, and now we have an exception, except x equal to 0. Have a multiplicative inverse and the name of the operation that gives you the multiplicative inverse is called reciprocal. So x becomes 1 over x. So generally speaking, when you see reciprocal, the usual place where you see it is with fractions. So like, what's the reciprocal of 2/3? 3/2. And if you multiply those together, you get 1. Now, is there a y so that 0 multiplied by y is 1?
No.
No, right? Because 0 multiplied by y is 0. That's why there isn't one of these. Finally, we have the last thing, so we can do the homework, and then we're done. So we will define x, and then with exponent -1. So far, all of our x's have had, none of them have had negative exponents. So here we have it. So this is the definition, 1 over x. That's its definition. And as a consequence of that, we could write x to negative n. How?
N over x.
Not quite. So 1 over x to n. So for example, x to negative 3 would be 1 over x to 3, like that. All right, so please turn in your odd homeworks on the way out.